All right, here we go. So on the agenda for today, we're going to review the in-class assignment we worked on Tuesday. We're going to review assignment 5. I graded all of that. It should be in D2L. Talk more about strings. Going to talk about some built-in character functions. So using some built-in functions that are native to C. So when I say built-in, talking about like functions like printf, scanf, functions that are included with C. We can determine what specific characters are. Let's say if we want to determine if a character is between A and Z, there are built-in functions to do that. There's also a couple of built-in string functions that help us do some operations with strings that we are commonly faced with. So the one thing to note about all these built-in functions, I'll talk about it more later, but all of these built-in functions are totally doable by us as the programmer. Yeah, very simply, but they're used so many times that they are included with C language. So we're going to review the in-class assignment. So recall for that I wanted you to read in 4 characters from the user. In one array, I wanted you to put them in the forward order, and in one array I wanted you to put them in the reverse order. So I will kind of have to apologize a little bit. When I was talking in class with people, I was using some of the wrong terms. I was saying maybe 4 instead of 3, referring to the array indexes when you needed to null terminate things. So whatever, we'll go through it and we'll talk about some of the things that make it hard. Okay, so need to do this as usual. We'll have our main. We'll have 2 arrays. Our forward has 5 positions, so that's 4 positions for characters, 1 position for the null terminator. We'll have backward, same thing, and then we'll have a intermediate for input. We'll have a index, and then we'll have a for loop. So we're going to say for I equals 0, I is less than, we need 4 total loop iterations, so we'll say less than 4. Increment I. What we're going to do is read into input, so pretty simple. We need to use %C because we want to read in a single character, so we'll read that into input. And then for right now, all we're going to do is store in the forward array. So we're going to store the forward array, and then we're going to print it out. So we'll say forward at position I equals input. So that will read in, okay, so 4 total loop iterations. So remember when we say I is less than 4, we're going to get whatever number is here minus 1. So we're going to get 0, 1, 2, 3, our possible index values inside that loop, 4 total iterations, remember. And then what we need to do, remember, we need to have a /0 at the end of our array. So we need to say forward at position 4. So 4 is our last position, even though we allocated 5 positions. Do remember that we do start at 0, so we'll say forward at position 4, which is again is our last position, equals the null terminator \0. So from there, all we need to do to print that off is say %s. We'll give it a new line too, and then we'll say forward, obviously, and return 0 at the end. So this is pretty straightforward. We didn't use backward yet, that's fine. So I type in ASDF, I get ASDF. So that's that. So in order to do the backward, we'd have to add on another index variable. So this index variable, let's call it j. It's going to, remember we can do this, we can put it inside of our for loop. We can start j at 3. So we'll start it at 3. And we don't need to do another condition because it's already going to run 4 total times. And then we will decrement j. So then we add the statement backward at position j equals input and print out backward. Same thing, we need that null terminator, that /0, at position 4 again. And if I've lined everything up right, it should work. There we go, so we got FSAD. So I'm going to talk about this a little bit more. So again, the reason we start this J at 3 is because, well, let's show it like this. So our forward, we're going to store at 0, 1, 2, 3, and that's going to give us our 4 characters. But our backward, we want to store at position 3, 2, 1, 0. So just the inverse order. But regardless, the string still starts at this first position. So we're going to store it in this order, but we're still going to result in, with forward, the 0, 1, 2, 3 is ASDF, and forward, and backward is going to be still 0, 1, 2, 3, but it's going to be FDSA. And then regardless of which order we need it to be in, position 4 still needs to be that /0. And I don't have an end key. That /0 at the end, because regardless of which order you store the characters, there still needs to be a /0 at the end, because when you start printing, remember it's going to print what basically the little algorithm we talked to print string last class was we start at the first position, so the first position is position 0, and we'll just continue printing out individual characters until we reach that /0 at the very end. So just think about that. So again, important thing to remember is so our total iterations, 4 minus 1. If we wanted 4 total iterations, we would have to say 5, or we could say 4 and then say less than or equal to. We need to say 3 because we have 0, 1, 2, and 3 total positions to store things in. So that's that. Any questions about that in-class assignment right now? All right. So we're going to talk about assignment 5 next. I'll go ahead and do it. I can do it on the fly, I think. So assign 5.c. We will need to include our stdio, so printf scanf as usual. And what we're going to do is go down to our main right away. And then I'm going to also fill out all of the functions that we'll need. Remember, the main point of this assignment was to do functions, so I probably deducted quite a few points if you did not use functions, because the whole point of the assignment was to use functions. So we will need a menu function that doesn't take any parameters. We have a choice. We return choice, and inside there we will read in user input, and we will print the menu prompt. So in addition to that, we will need the add keychain function, and the current keychain is the parameter. So again, we'll need the choice, print, enter the number of keychain, add, read into choice, percent, and then we will say, well, we'll just return it. We don't even need the intermediary variable. We'll say current keychain count plus choice. So that's all we need for the add function. Subtract is super similar. I'll just copy it down. Or we'll call it remove. And we'll change the text to remove. And then we will subtract instead of add. So we need to have a display order function. Remember, I believe that one is void, does not return anything, does not manipulate any data. So we'll say view order. For this one, we will take the keychain count. We need to take the keychain cost. And that's all the parameters I believe we take for that one. And then we'll just say we need to calculate the subtotal. We need to make that a double value so we can store our decimal. And we'll say subtotal equals keychain count times keychain cost. Then we'll say you have keychains it will, the prompts are similar to the other program I wrote, whatever. It will cost you %L or %F, float, do LF2, that's fine, and then subtotal. And that should be all we need for checkout, or for view order. And then finally we have checkout, so we have void checkout. That takes the keychain count, the keychain cost, and the tax rate. So I'll just copy all this down. We need to change the output a little bit. So we calculate the subtotal. We'll also need a value for total. So then we'll say total equals subtotal plus subtotal times our tax rate. And we will change this to say your subtotal is, and then printf your total is. Alright, and that's pretty close to what I think the program was supposed to do. So with that, we need to go down to our main. We'll need to have keychain count. We'll need to have keychain cost. And we'll need to have tax rate. So we need prompt for all of those. So enter the keychain or the cost for keychain. Same thing for the tax rate, all over the place here, enter the tax rate. And then we will also need a variable for the choice. Now, when I do this the first time, I'm going to try and do it with a do while loop because that makes sense to me. So what we're going to say is do choice equals menu. So every time we run the loop, we're going to do the menu. Then we're going to switch on choice. We could do a if-else if statement as well. And then our terminating condition will be while choice not equal to 4. So we'll say case 1, we will call the add keychain function and store the result in key count. So we'll say key count equals add keychain key count. Remember, we have to pass that key count in there. Because it's not manipulated inside of the function, we have to pass it in. We have to store the result inside this variable. because again, it's not manipulated. We're only copying the value to the function. In order to preserve that value and return it from the function, we do need to store it back inside of there. So one thing to note is when we provide a value to the function, that value is copied first, and then once that value has been copied, we call the function and then store the result in key count. So you don't have to worry about these variables being used at different times. That's perfectly valid. So break case 2, key count equals remove key, I think I called it. Case 3, we'll just call view order, I think it was called. In case 4, we will check out. Okay, remove keychain. Did I call it that? I called that right. Just got to do our menu quick, and then we're all done. So we will say choice 0, and there's all other minor prompts that I'm missing, but you get the idea of the main functionality. Add keychain. Remove keychain. View order. And check out. So we'll read into choice. With %I. Return choice. And I think we're done. Clearly not. Using wrong there. View order, didn't do that. Okay, gotta change a few things here. On my scanfs here, use the wrong format specifier. Those need to be LFs because we're reading into a double value. When I called view order, I did not pass in the keychain count and the keychain costs. I need to do key count, keychain cost, and the same thing for checkout. I need to say key count, keychain cost, and the tax rate. And now I think we're good to go. And I need to return 0 at the end of main. All right, cost per keychain, we'll say $5.99. Tax rate 0.07. We'll add a keychain. Let's add 2. Okay, we'll view order. So 11.98. That makes sense. You need to print it to do 2 decimals too. Just changed it to be 0.2 or %.2f. That works. So let's remove a keychain. Remove 1. View the order again. Now we're only at $5.99. Let's add 2 more, so now we're at 3. View it one more time, so it will cost us that much. And finally, now we check out, and it calculates subtotal, tells us how much we have, and prints the total. So that's the assignment. Again, I missed a couple little prompts, a couple little things that you're all supposed to do, like checking for invalid input in your loop. So if your menu returned a choice that wasn't any of your cases, you should have had a case default or an else statement inside of your if block to catch any invalid input. But yeah, that's it. Any questions? Anything else you want me to cover on this one? Also, probably printing $signs and stuff. I didn't check that close. As long as you, the main point of this assignment was to definitely work with functions, and as long as your approach had valid functions that seemed to make sense, that the values were working, then I should have given you full credit. So feel free to ask any other questions you have later. I'll stick around as usual. So, reviewing strings. Yeah, I kind of already talked about that with the class assignment. But one of the things, I guess I'll go back to the class assignment again. So, one of the things you might have noticed is, let's recompile this. And let's say ASDF. And that works perfectly. But let's say we want to type these characters in one at a time. ASD. Oh, whoops, what happened there? So what ends up happening when you're typing in characters in multiple lines, when you hit the enter key, you're actually getting a \n written to your input. So you can see here, let's run it again, and let's count the number of characters and enters we hit. So we hit A, enter, that's 2. A, enter again, that's 4. So we're already at 4 characters with the characters we type in and the new lines at the end. So when you use %C, let's look over here. When you use %C with scanf, that's going to not only read in the characters on the keyboard, it's also going to read in the /n's when you're hitting the /n's. So this will be kind of fun. Let's do this. Let's write a quick little function which will ignore all of the /n's that we see in our input. So we'll call that char. We'll return a valid value that's not a /n. It's a number, a digit, a symbol, whatever we can type on the keyboard. So we'll say get real val. We'll call it. So all we need is a input variable, and we'll say do wow, and we'll read into input, read a character into input, and then we'll say while I'm doing that wrong. While input equals /n. And what that will do, this loop will continue running. It will keep reading characters until it gets characters that aren't new lines. So as soon as it finds something, is like you type A, it will immediately, after I add this last statement here, it will immediately return the input. It will return the value that was read, the valid value. Otherwise, it'll keep spinning. It'll keep running over and over again until we reach a character which is not a new line. Now, we could filter out any other character by this approach. Let's say, well, let's do this first. Let's go and just run it quick. So we'll say input equals get real val, and we'll call that. And now, theoretically, if I know what's going on, what will happen is when we're doing this, it still works just fine. But now when we do this, now we get it like that. Filters out all the new lines just like that. So we can kind of take this approach with any other input we want. Let's say we wanted to filter out the letter A or something, so you couldn't type A. We could just change this /n to be an A. That's completely valid as well. So when I type ASDF, oh. Okay, so slightly different thing happened in this case. So I still am hitting that enter at the very end. So it's reading SDF and then new line. So if I was to instead type ASDFG, now we would ignore that first A and we'd only read SDFG. So even though you might have only been typing it on one line, there's still that new line in your input buffer, as they'd call it. And if you continue to read on at another point, you're going to still read that new line that's still there. So it's kind of an interesting function if you need to read characters and you want to strip out your new lines. So another little cool function you can add to your repository right there that you've hopefully been building. So the reason I kind of talked about that now is we're going to extend this functionality with these built-in character functions. So hopefully in your reading you should have seen this. So there's a couple different character functions that we can use to operate on individual characters. So these are the first ones we're going to look at right here. This is alpha, is digit, and is space. So let's say we wanted to only allow A to Z characters to be typed in for this get real val input. So what we'd have to do is say, well, input is not equal to, what was our function here? Is alpha, and then input. So that will, again, return true if input is an alpha character, so A to Z, uppercase or lowercase. So we'll return true. So sorry, this is wrong. We're not checking if input's equal to that. We're saying if not is alpha, basically. So we're going to take the trueness or falseness of the return value here, and we're going to negate it. So I believe we're also going to have to include stdlib.h to be able to use this function, if I recall correctly. Maybe I'm not. Alright, so okay, sorry, it's C-type. You can see right there, I should have seen that. So you need to include ctype.h and able to be able to use that function in order to be able to. So now when we're typing in, let's try and type 1, 2, 3 here quick, or 1, 2, 3, 4. That input is completely ignored. We're also going to ignore the new line as well, because that's obviously not A to Z. But if we were to type let's do our traditional example of ASDF, and now we can see that's inputted perfectly fine. But, so it's all powered by, where am I at here? It's all powered by this loop right here. So when this function call only returns when it gets a valid value. So we're just going to sit inside this loop as long as we need to until we get a value that we can use. So same thing with the other functions. We could say isDigit. So we could go back and change this isAlpha to be isDigit instead. And also completely valid. Recompile it. So now when I type ASDF, try it again, try it again, try it again. No matter how long I try, it's never going to work. I'll type 1, 2, 3, 4. And now those values are accepted because that loop, that condition, again, for each of the values that were accepted, that loop condition has to become false. It has to return that value. It has to go through the next iteration of our loop down in our main, right here. It has to go through the next iteration of the loop to get a new value. So finally, let's say we wanted to, let's change this around the other way. Let's say we wanted to remove all white space. So when we say white space, it should be spaces, should be new lines, should be tabs, and that's about it. So in order to remove all of those characters, but allow all of the other characters, we would, instead of negating the condition, we'd say is space and input. So again, that's going to return true if the input is a space, and if it's true, our loop's going to run again. It's going to read another character. So there we go. It filters out all of that white space. Let's say we hit a bunch of enters, hit an A, another bunch, and then finally S. And it still works perfectly fine. So that's the example for that. So it's pretty useful functionality when you're reading individual characters. You definitely got to remember that there's that new line there that we got to take care of. And by writing a function like this, which just strips out all of the white space. Again, you could rewrite it so it only strips out the new line. Again, by saying something like this, while input, was it equal new line? Yeah, while input is equal to a new line, we're going to try and get the next character. So if you just want to get rid of new lines, you can do that. If you want to get rid of spaces, you can just say is space, and it will continue to read until it finds something that isn't a space. Otherwise, you could say not is alpha, and it would return only alphanumeric characters, or not numeric, sorry, just alpha, so A to Z, and then digits. So that's that. So definitely interesting functionality. So for all of those character functions, it's worth noting that this is alpha function and is digit is space. Those are all functions that we can actually do ourselves. So, well, we can't reuse their names. What we can do is say bool my is alpha, and we take a single character as a parameter to that function. And what that function would look like is something like this. So we'd say if C is greater than or equal to capital A and is less than or equal to capital Z, we're going to return true. So we talked about this quite a while ago. That's not what I meant to say. Whatever, it'll come up anyway. Magic of Google. So remember, we have our letters are represented something like this. So every letter that we have has a unique value. So when we say something like this, when we say C is greater than or equal to A and, so remember when we say and, both of these conditions need to be true. So and C is less than or equal to Z, what that's going to do, we're going to find A, it has the value 65. Going to find Z has the value of 90. And if the value of our character that we passed in is between those two numbers, then we're going to return true. And that's pretty much how I would assume, I can't say for sure, I haven't looked at it, but I'd pretty much assume that's the how the actual is alpha function works. So remember, we have another condition here. So we'll say else if C is greater than or equal to A and C is less than or equal to Z. And that will test for lowercase, return true. Also a alphabetic character, I would say. Otherwise, if we haven't matched either of those conditions, we would return false. And there you have it. So the reason we have to do both of these, so we have to do greater than or equal to A, capital A, and we have to do greater than or equal to lowercase a, is because we have our ranges here are separated by other special characters in between here. So you can see here our A again starts at 65, Z ends at 90, but we have this gap where we have a couple other characters in here which we would not want to match. And then our lowercase a starts out at 97 and then finishes with lowercase z at 122. So if all of these characters are all right next to each other, if we wanted to, let's say, test if we had a, well, let's do this example. We'll test and see if we have a uppercase letter, a lowercase letter, or if we wanted to test if we had any of these symbols in between. So we had left bracket slash, right bracket, caret, underscore, or apostrophe thingy, probably. Yeah, that's apostrophe. If all we wanted to do was that, we could extend our condition and only do one test. We could test all the way to lowercase z. And that would test all the way from this capital all the way for any of these values all the way down to this lowercase z right here. So all of these comparisons that we're doing all rely on these ASCII values that are associated with each letter. It's just numbers, just numeric comparisons, just like any other. It just happens that these characters have values associated with them. So that's how all of those classes of functions work. If you wanted to say, look at the isDigit function, very similar. You just say 0, so character 0 has the value 48. You just say, let's do that one really quick. You could say 0, so it's greater than 0, less than 9, and that would return true for my isDigit. So yeah, there we go. It's important to note that the character 0 and the character 9 are not the same things as the integer value 0 and the integer value 9. With characters, they have their own values associated with them that recognizes that those are actual characters. So when you see a character 0, you can't just you can't do something like this. You can't say int this equals that. So this val will be 48. It won't be 0. Now, random thing that you could do, let's say you had a character 0 and you wanted to convert it to a integer value. So one of the things you might notice is since all of these values line up, what we could actually do is take our character value that we know is a digit and subtract 48 from that value. So let's do a little test right here. I'll need a new file. I should really have a template to do all this so I don't have to type it out every time, but that's fine. So we'll just have a val, we'll set it equal to 0, and we will print it out. ahead and ignore all that. So 48, we can see that that's our value, so 48. We could, so what we could do is, knowing that 0 is 48, what we could do is subtract 48 immediately from it. If we had a character that we knew was a digit and we wanted to convert that to a number. Recompile that again, and now what happens is that 0 is a 0 since we subtracted that 48 from it. So let's try this. Let's just put 7 in there and see what happens. Hopefully we get lucky. And look at that, it turned out to be an integer value 7, subtracting 48 from it. Because, again, what happens is we go to this table, we see character 7, we go over here, we find its value, so we got 55 minus 48 gets us 7. So you can do that with strings too, like let's say, I mean, obviously you could replace this with, you could do that, you could do that, or you could do this. Remember, we can do something like that and put equal to 7, and then do a at position 0. It's all the same, it's just finding characters in that array of characters. So yeah, that's our working with values. I think there's one more thing. Yeah, there's these other functions right here. So I have these other functions called 2upper and 2lower. So if you give these functions a uppercase, or you give 2upper a lowercase letter, it will give you an uppercase letter. You give it anything else, you give it already, like you can see here, the examples are, you give it an uppercase letter already, it will still be an uppercase letter. You give it a number, it'll just ignore it, it'll continue to pass it through. So super simple. Let's go ahead and write out a quick little loop here to convert my sentence thingy here to, we'll keep it 10 for now. We'll say ASDF, since I I love ASDF so much. So we're gonna say void make string uppercase. I don't care about passing in length right now, it's just an example. So we'll set our length equal to 10. And we'll say for, we need a loop, I equals 0. Going to say don't need that equals 0 since we're doing it in the loop anyway, so we'll say equals 0. I is less than len, increment I. Well, I do need a parameter here, I'll need to pass in our array. And that we'll just say is str at position 0, or at position I. Remember, str is our parameter. So whatever string we pass in, str at position I equals, was it 2upper? 2upper, yes. 2upper str at position I. So get the value at position I, pass it to that 2upper function. If it happens to be a lowercase number right now, it will make it an uppercase letter, and then it will store the result in str at position I. So remember, when we're passing arrays to functions, the values inside of those arrays are manipulated inside of the function. So when we do something like this, when we call make string uppercase and pass in a, and then we'll go ahead and print it out. I don't care. You can see that it made our entire string uppercase. So could do the same thing with lowercase. All I got to do is change this function name to be to lower. Yep. And there we go. We got our lowercase string. So we've got this warning right here, remember, implicit declaration of function toLower. In order to solve that one, we're going to need to go up to the top, include ctype.h. Run it again. Still not returning from the end of our main, doesn't matter. Right now, I wouldn't like it if you did that, but I'll do it anyway. And there we go. So we got we get to see all these functions. So you can use those to manipulate all sorts of different things. So, final thing I wanted to talk about today was some other built-in string functions. So these functions that we just talked about right here, these are all for individual character operations to test individual characters. And if you want to do things with these functions, you'll have to write other code to do things with them. So you have to write loops to test, to do things like that. So one thing that we can do is there's also a bunch of other string functions that are provided to us. There's one other one here that I wanted to talk about first. So the first one we'll talk about is the string comparison. So let's say you have two strings and you want to test if they are equal. So if you have two strings, let's say you have this. Let's say you have A, we'll just stick with A, and we'll have ASDF, we'll have B equals ASDF. Let's say we'll do this. We'll see how this works. We'll say A equal to B. Yes. So you might look at that. You might think, oh my goodness, that's going to work. So we're going to run that, and there's no yes printed out. So what's actually happening here is each of these arrays are just really just a location memory. So when we do this, we're just comparing the locations in memory. So what we could do is if we wanted to compare one single location, we could say A at position 0 or B at position 0. We could compare those individual positions. And that's true, because A and A are equal. But when we do something like this, we're just comparing kind of where they're at in memory, and that's going to be false. So what we actually have to do is we have to have a function which will go through each character in each string, and it will test to see if those two characters are equal to each other. So our function will go and it will say, is A at position 0 equal to B at position 0? If it is, then we'll continue on to the next character. So A at position 1, is that equal to B at position 1? Then it'll continue on to the next character, so on and so forth. So there's actually a built-in function in C to do that. It's called strcmp, so string compare. We do have to do this include string.h when we are using it. So include string.h up at the top. That allows us to use that function. So then what we need to do is strcmp string compare a b, and if the result is 0, then we print yes. Recompile it, and there we go, it's yes. Let's go ahead and change our string right here. Let's make it all A's, and it's no longer true. So I'll talk about this more as we go along with other functions, but just like any of the other string comparison or string operation functions that I'll talk about today, all of the value that they give us, they can all be implemented by us as the programmer. But they are, these operations I'll talk about, these other functions that are used so frequently that C includes them for you to use. So we could do, just like I did with the my is alpha function, we can write the same thing. We can say int my strcmp. We need to take two strings as parameters. We'll call it left, we'll call it right. Inside that we will say, remember our pattern was something like left at 0 equal to right at 0, and so on and so forth for the entire length of the string. So before I do that, it's worth pointing out this one function that will make our life a lot easier. I don't know where it's talked about here, but anyway, there's a function called strlen, which will give us the length of a string. So let's just show how that works. So I'll say length is %i, and then we will say strlen a. Messed up somewhere. I left off my if condition here, so I'll just put that to true for now. 1 since I haven't included standard bool. That's fine. So length is 4. So it will give you the total number of characters you have minus the null terminator. So we can use that in our functions. We can say len or int len equals strlen of left, and then we'll also have a index variable. So we'll say we'll say for I equals 0, I is less than len, increment I. And then what we'll do, we'll say if left at position I equals right at position I, we are going to, or we'll say not equal. That's a better way to do it. We'll say if we reach a character position where the character from the left string and the right string are not equal, what's going to happen is we are going to return 0 or return false or whatever. Let's do return false. Let's make it a little bit more clear. So we'll say return false. Again, in order to return true and return false, we need to include stdbool.h. All right, so that will go through every single position up until length. So in this case, it will our length will be 4 since we're passing an ASDF. So we have 4 total positions. So it will be 0, 1, 2, 3. Generates 4 iterations. Goes over everything in the loop. And then if we meet anything inside of that loop that is not equal, we're going to return false. So if we get to the end of the loop, we haven't seen anything that's not equal, then what we can do is return true. All right. So then we'll call it my strcmp AB. We'll pass in our 2 strings. So right now, those 2 are not equal. We see we have this right here, and it needs to be ASDF. And now those 2 are equal, so we get a true result. So one thing worth noting, you might have noticed it in the text and versus my example here, is my string comparison example returns true when the strings match and false when the strings don't match. But the actual strcmp does it a little bit differently. So it will return 0, which is actually false when strings match, and it will return 1 and -1 under different circumstances. So if you use this strcmp function, you need to say equals 0 if you want your code to be executed when true. So if you were using the strcmp, what you need to say is equals 0. But the way I wrote it, kind of a little better in my mind, is like this, where we return true when our condition is true. So a couple other things that the built-in str comparison or strcmp function doesn't do is, let's say you had 2 strings of different lengths. So how would you just, it's a tricky problem, but how would you decide if 2 strings of different lengths aren't equal? So what we could do is we could say len left equals this, and len right equals that. And then right away, we could say if len left is not equal to len right, we could return false right away. If our 2 strings weren't of equal length, we know they couldn't be equal anyway. And I don't recall exactly how the built-in string comparison function works. And it might stop at the null terminator for each of them. I'm not positive. I'll do a quick little test here and see what happens. We gotta change one variable here to get it to work right. Try it the other way around really quick. Alright, so the built-in string comparison would look like something like this. If the two lengths weren't equal, it would actually end up, in fact, returning 0 to indicate a true return value. It's confusing, but that's just the way it works. But if we were to leave off our condition, if we were to leave off that condition on our mystrcmp function, what would happen would be we'd see something like this. strcmp, and we passed in this. So our right length was greater than our left length. So we would just test, what would end up happening is we just end up testing up until the number of characters on the left parameter to that function. And we'd end up just ignoring the rest of the characters. So that's something that the built-in function takes care of. It takes care of maybe a couple of other conditions that you might not think of right away. So yeah, but I just wanted to show you that all these functions that we can use, they're all just C code. They're all doing things that we should know how to do at this point, but you can just use them kind of to save time and so on and so forth. So we talked about strcmp compared to strings. We talked about strlen, get the length of the string. And now what we're going to do is talk about a couple other ones. So we're going to talk about strcopy. So it's going to copy a source string. So source goes on the right, destination goes on the left. Copy source to destination. So let's say we had this. Just print out B. Let's do that. Not %B, %S, sorry. And let's say we'll give it 10 positions. So we have a empty array. What we're going to do is we're going to strcmp, so copy into B from A, and then we're going to print out B. Sorry, I did a strcmp, not a strcpy. So that's a stir copy. Called the wrong function. So yep, so we had that A, copied it into B, and printed that value out. So again, stir copy to copy from one string into the other. A very simple algorithm. It just goes until it hits the null terminator, it takes a character and puts it inside of this other array. Very simple. We don't need to go through that one. So stir n copy, so copies up to number of characters. So one of the things that we kind of need to manage, remember we talked about this on Tuesday, is this is a limited number of space, and if we try and fill more characters in that space than we have available to us, we're going to start overwriting memory in other locations. So when we use this stir n copy, what that's going to do is it's only going to copy number of characters. So we have to provide a third argument, let's say 10, and it will only copy 10 characters from our source to our destination. So let's say we had a source of a whole bunch of characters like that. All right. So what's going to happen is we run that, and it only copies 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then one position is reserved for the null terminator, I believe, if I counted that correctly. No, it's actually not. So we'd have to this is actually kind of a tricky problem. I don't know if it reserves space for the null terminator or not. What we'd probably have to do is we'd have to say 9, and then we'd have to say b at position 9 equals null terminator, like that, to ensure that we have a null terminator at the end. Because I don't believe that stir copy does, or at least stir and copy doesn't ensure that there is the null terminator at the end. And the final function I want to talk about today was stir cat. So it copies the source string and it appends it onto the end of destination string. So let's say we had one ASDF right here. Let's have an ASDF in a space, because that'll make things easy. And we'll have like 40, well, we'll just give it 100. That's fine. So what we're going to do is we're going to set our array, zero that entire thing out. That's required to get strcat to work. And we're going to say strcat, our destination on the right, b, and then a. What that's going to do is going to take this ASDF and copy it onto the end of b. Now, since we've zeroed out b, the end of b happens to be the first position, so it'll put it in the first position. So let's go ahead and run it and print it. Am I printing the right one? Did I put it in the right order? Destination. What? I didn't compile it. Perfect. Alright, so there we got one ASDF. So let's go ahead and call it again. Let's call it a couple times. So what will happen is it will append one ASDF onto the end. So we'll get ASDF, 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 and ASDF. So we should get 4 total ASDFs. Run that again, and there we go. We successfully built a string. So let's extend that a little bit. Let's say let's have input with 100. We'll have output also with 100. And then we'll have some different little strings here. So what I'm going to try and do is this program will ask, or it will prompt for your name, and it will say hello your name, and then it'll like say exclamation. Well, it'll just say hello and then your name. So we'll say, we'll just do this. I think we can do this. We'll say hello, and then your name would go right there. So what we're going to do is, let me see if I can compile this really quick. I don't know if I can. Yes, I can do that. Okay. So what we can do here is put a semicolon there. We can scanf, read a string into input. Then what we'll do is we'll strcat the input onto the output. Then we'll print that out. So we need to change this variable to be output instead. So I'll say Alex, and then it will say hello Alex. So we can build strings with string or strcat. I'll compare them with strcmp, get their length with strlen. And we did copy. There's a couple other ones we could do, but that's all you'll really need to know. Like, you could search for a character, so you can see here. Provide the source string. It will see if a character is inside that string. Here is our strlen. So we search for the length of the string, returns number of characters in the source string parameter that we did there. And that's our strcmp function that we talked about earlier. So yeah, I think that's pretty much all I had. As I said before on Tuesday, strings are really difficult in C, and it's unfortunate that they are kind of this difficult. But one of the things about C is it tries to emulate the actual memory structure that we are encountered with on a computer. So on a computer, you only have individual bytes of data, 8 bits, if you know what that means. And there's no actual like string type in the computer. It's all groups of bytes underneath everything. Again, in higher level languages, let's say your Python, your JavaScript, everything like that, they do have built-in string types. But underneath it all, it's all represented by individual bytes, individual values that are all attached to each other that have some indication of where they end. In this case, in C, that's the null terminator. Other languages might store a length with the length of the string to indicate how long it is. Again, in C, we use the null terminator. But yeah, so that's what I have for strings. Stick around if you have any questions. Hopefully, unfortunately, I was going to get an assignment together today for arrays, but that didn't turn out. So I didn't get that done. So well, unfortunately for you, what I'm probably going to do is give you 2 assignments next Tuesday. So it's going to hurt. It's going to be painful. But working with arrays, working with strings is super important. Just like any other concept we've covered in this class for your understanding of the C language. As you might have noticed, we did reach the last chapter in the book. There's a couple other chapters. All of this stuff is stuff that we covered in CSC 250. So if you want to look at any of those, by all means do so. But this is the last chapter of the book, so that is the end of really new material in this class. So up until this point, there really isn't going to be anything new that we will cover that will be required knowledge for this class. So everything that I've taught up until this point, that's pretty much what's going to be on the final. There really isn't going to be anything else. So if you practice this material for the next 2, or what do we got, 3 or 4 weeks, up until the final, and you understand it well, then you shouldn't really have any problems finishing out this class. But what we will do in the next 3 or 4 weeks, so I talked about this briefly on Tuesday, so we're going to spend lots of time next week working on assignments, looking at more examples, just making sure you understand what's going on. Then also, going to spend some time looking at other programming languages. Okay, maybe spend some time looking at like what a enterprise grade C program is, even though I don't want to open one up. But it's a good reference. There's a lot of different things when you're looking at other C code that really won't make sense because I haven't talked about it. It's more formatting stuff more than anything. Maybe some other general coding guidelines, things that you could think about when you're writing programs. I don't know if we have time to talk about. This is really just miscellaneous topics for the rest of the semester. There will be assignments on some of it, and there will be daily assignments, just like before. But again, all the material that we've learned up until this point, that's all you'll need to pass the final successfully. So definitely spend the next couple weeks. If you don't understand the material, keep getting in there, keep thinking about it. If you haven't, I guess reading assignments are all done, but still take a look at them if you haven't. Gives you lots of good examples, things to practice if you want to. That's all on you. So that's all I have for you today. Stick around if you have any questions, want to talk about any grading stuff. I'm here for you.